This is my thermonuclear reactor. So you can see me, but difficult to set up. This is the coil which is used to generate high voltage across this here, across the tube, and then the windings generate a high current in this tube, which has got hydrogen in it, a low pressure, that goes in there like that, and it resonates against this capacitor here, which is connected to these inner connections, and then this coil here is connected to the pulse generator here and here, and then this outer coil here is connected to a regulator. What happens is that the exciter, which has got a power supply here, which is not shown, generates electricity in the coil, alternating current in this coil, this coil here, that induces a current in here, and there's about 6,000 volts across here, which strikes an arc in this tube, and then when the arc is struck, it conducts electricity, and therefore the current, low voltage pulses in this inner coil, which are high current, well, it doesn't matter whether it's this or an outer coil. There are only 8 turns in this outer coil, so there's 10 amps through the outer coil, so there's 20 amps. There's 20 amps through here, so there's 200 amps in this coil here, because it's one turn, 10 to 1. 10 to 1 is 200. There's 200 amps in here, and because it's a small space, it's only a few millimeters, 30 millimeters across. The current density is about 900,000 amperes per meter squared, around this way, around the outside, around here, and that generates heat in the centre of the coil. You see it's slightly dented from previous experience, just here, and that ignites fusion. And when the heating in this fusion state, the fusion between light nuclei of protons and protons, generates heat, no neutrons, a bit of gamma rays, generates heat, that expands the ionised gas against the magnetic field in here, which generates current in here, which is picked up by an outer coil, which I haven't put on, which generates power outside. Now this coil here, when the power is too much voltage, it switches on this triac down here, this triac in here, switches on this triac, which then stops it increasing. It's a shunt regulator. This here is a pulse generator. It's what's called a slick control rectifier. We used to call them diodes, I think they're called thyristors now, thyristors. And the pulses from the pulse generator go in here, the voltages across here, and when they're finished here, the current come out there, out here, and generate electricity. That's the idea, direct pulses of about 10 amps through this coil. And 10 amps at 10 turns is 100 ampere turns. So therefore, and because of resonance, it's about twice that. The Q is about 2 or 3, and therefore it'll be 300 ampere turns, 300 ampere turns, and therefore because only one turn here, there's 300 amps in the plasma. 300 amps in the plasma generates a current through here, and because it's small, a metre is out here somewhere, it's much less than a metre, so therefore the current is much higher density, and therefore I get a current density of about 900 to 100 to a million amps per metre squared, and that's sufficient to ignite fusion in the coil. The heater then pushes the coil, pushes the platter outwards. That generates by induction, normal laws of induction, produces current in the coil, and that keeps the oscillations going. That's the theory. This is a trial run. This is made of plastic, so it won't take high temperatures, so it probably won't be functional. but that's the idea, is to demonstrate it. Okay, demonstrate the principle. I wonder if that records anything. Thank you.